Hi friends, welcome to follow up. Let's have a look at problem 1759. Count number of homogeneous substrings. This problem is today's daily challenge problem. So in this video, we are going to provide two formats of solutions based on the same idea. So the strategy is the following. We are going to break the string to be a number of longest homogeneous substrings. Then we do the counting. So with that said, our plan will be the following. First, we are going to digest the problem requirement, and then we look at the logic and the walkthroughs, and finally we look at the codes. So now let's look at the problem. So here we are given a string S. We want to return the number of homogeneous substrings of S. Here, since the answer can be very large, so we return it modulo a big prime number, 10 to the power 9 plus 7. So here a string is called homogeneous if all the characters in the string are the same, right? So a substring is a contiguous sequence of characters within a string. So with that said, let's look at the examples. So in the second example, so we return 2 because the letters are different, right? We could only have X and Y individually, so we have 2. And in the third example, we have 15. Actually, the 15, if you look at the here, so we can consider length 1 homogeneous subarray. We're going to have 5 of them. Then we look at length 2 homogeneous subarray. We're going to have 4 of them. Similarly, we can look at length 5, so we're going to have 1. So 1 plus 2 plus 3 plus 4 and plus 5 together is 15. That's the return for example 3. Actually, if I explain like this, you might have already guessed what the logic is. So now let's look at the first example. The return is 13. So this here are some explanations. But here the explanation is sort of misleading, but it's correct explanation or one way to explain the output. So with that said, let's look at the constraints. So here S is not empty, and its length is bounded above by 10 to the power 5. And S consists of lowercase English letters. So with that said, we are ready to look at the strategy. So the strategy will be the following. So we are going to break the string to be a set of longest homogeneous substrings. And then we do the counting. So here the main observation is the following. A homogeneous string or substring of length n contributes to this 1 plus n times n over 2. In other words, the summation of 1 up to and include n, right? So here actually it's very easy to understand. For example, if n is 3, right? We have AAA just for demonstration. Then the length 1 homogeneous subarray will be 3, right? Each A is a qualified one, so we qualified one, so we have 3. And length 2, we can consider the first 2 and the last 2, so that is n minus 1, right? Length 3 is going to be 1, right? We have 1 plus 2 plus 3. Actually, this is the summation is nothing but 1 plus the n times the number of atoms divided by 2. That is 6, right? So now if you look at the walkthrough for example 1, you get the following explanation. So you break this, so we have A and BB and CCC and AA. So here n is 1, so just contribute 1. So here n is 2, so contribute 3. And here n is 3, contribute 6. And this 2 contributes 3. So in total we have 1 plus 3 plus 6 plus 3. That is 13. So that's the way we count that. However, we should notice that if the length of the string S is very long, so we need to do the counting modulo a constant or big prime number. So with that said, basically we are ready to write the code. First, I'm going to write a sort of verbose one to just break the strings. So break, I should add a quotation mark. We didn't really break, but you can if you like. So here, let me first introduce this variable, this result. It's a counting variable, right? Then the previous character will be S0. So we can do this based on the assumption that S is not empty. So next we're going to iterate, right? So for I in range, so we start from the index 1 and ending at the length S minus 1, right? So now we want to check if Si. So here, let's see, also we need to count the length of this consecutive piece, right? So if Si equals previous, in this case, we need to increment the length. Otherwise, so we need to update the result, right? Because the length is given, so we just need to compute 1 plus this length, multiply this, then into division by 2. So you can think of this length corresponding to the n above, right? So after we do this, we need to reset the previous to be the current character, and then the length should be 1 now. So afterwards, we need to make a final check. If I equals the length of S minus 1, we should do the increment result, right? In other words, the last chunk. So what we want to return is this result. So modulo this large constant, let's see, 10 to the power 9 plus 7. So here, I guess we need to first treat a special case. So if length of S equals 1, so we just need to return 1 because it's just one character, it contributes to 1. And then we are going to enter this for loop and get this result. So here, let me do things like this. This might be better, right? So I treat a special case first and then do general case. And though if you like, you can try to absorb this edge case into the general for loop. So let's do a test. So the first example passed. Now let's look at the generic case. Yeah, it passes all the generic cases. So now I want to write another solution. But this time I'm going to use an iterator function. So let's use this one as V1. So I want to use iter tools group by. So the function I want to use is iter tools group by. So I want to group this or do this split using a function. So actually in Python we have this function. So I'm going to write the result as 0. This just for, and then I do the group for key G. So here key actually this is just the dummy for key G. It's group in iter tools group by. So here S. So here as a key, I will write the identical function. I don't specify it, right? And then what we want to do is that, so let's get this length. This is the length of this G, right? So let's see, but list, make it a list and find the length. So each group actually is corresponding to one of those. This is the one group, this is the one group, and this is the one group, right? Then what we want to do is just do result increment by 1 plus length multiplied by length over 2, right? So afterwards, we just need to return result modulo this constant. Actually, you can do this modulation here also, but to just see, I just do it here. So let's test this case. Yeah, it passes all the cases. So here I want to maybe to make it even better. I can print out this group by so that you can have groups. So here let's see iter tools group by this S, right? So let's do this. Maybe it's better. Let's see. I can make a print because it will return some iterators. I'm going to use for list G for key. This is basically the key, and G in iterators. So basically this is dummy. You can just make like here. So let me print this for you. Right, for this we're going to have A and B, C, and AA. So here for the first one, the key will be A, the second one key will be B, third one key is C. Similarly, the last one, the key will be A. So actually in this function call, you can specify a key, right? So the key, the group by will change or start a new group if the key value is different. So if you do not specify the key function, so this key will be the identity function. Basically, if the letter changes, it's going to build a new group. But if I write a key like this, lambda, so let's say I map all the elements to 0, then we just have one group, right? Because you compute the value according to this function, it does not change. Let's check that. Yeah, you just get 1 because all this going to give you 0. So now let's ignore this part. Right. So if you print out this, so you are going to get this one. So with that said, I guess that's basically about it for this daily challenge problem. So here we presented 2 formats of solutions based on the same idea. That is, break the string to be some longest homogeneous substrings, and then we do the counting. So in the second method, we explained or introduced this group by function. So this function actually is very useful even in your daily work. So with that said, I guess that's about it. So we have a collection of videos, more than 700 for now. So if you are interested or want to practice, we hope that those videos can give you some hint or give you some stimuli. So with that said,